Have you tried building a complex UI in React and felt like your code is turning into a tangled mess? Don't worry, you are not alone. In this video, I will show you how to make your React component more flexible and organized using something called compound components. By the end, you will know exactly how to refactor messy code into a clean, maintainable structure. Let's dive in. So, what exactly are compound components? Think of them as a way to build more complex and flexible UIs by breaking them into a smaller, reusable pieces. Instead of having one giant component that does everything, you can split into a parent component and multiple child components that work together seamlessly. This approach not only keeps your code clean, but also makes it much easier to manage and extend. But before we start coding, let's make sure you have everything you need. You need Node.js installed on your machine, of course, and I recommend you using a code editor like VS Code that I'm using. Of course, you'll need React installed in your project, along with a basic understanding of React components. And if you are new to React, don't worry, I will walk you through everything step by step. Let's jump into the code now. So we are going to build a simple real chat application. First, I will show you this ugly code version, which is messy and hard to maintain. Then, I will show you how to refactor it using a compound component to make it much easier and much cleaner. Now, we have here a chat component, okay? And this chat component handles everything for us, displaying messages, sending new messages, and dealing with the real-time updates. The problem here is that it's all jumbled up together, making it hard to track and what is going on. So if you go deep into the code, you can see our chat component. It's having a state here, which store the list of messages we are going to send. And then it have a function here that will handle the submission of our messages using the socket. Okay. And then we have two child components. One is for the window to display the messages, and the other one is the message input. And let me open the UI so you have better understanding. So this is the interface we are trying to build. So it is like a message box. Okay, so I can say hi, send, and should display it there. Okay, I am a coder and send. Okay, so this is the app we are trying to build. So we have the chat component, which is a wrapper around the whole thing. Then we have the messages component. Okay, and then we have the other component, which is the message input. Now, what is the problem here? We have few issues. The first thing is the prop drilling. Okay, so the messages here, the state messages and onSend function, which is right here, okay, are passed down through the props, which make it harder to manage as the application grows and scales in the future. The other problem is the tight coupling. This chat component is tightly coupled with the socket logic, as you can see here, okay, and making it very difficult to reuse and test it as well independently if you want to. The third problem is there is no separation of concerns. The socket event handling logic is mixed up with the chat component, okay? So usually you should not see these logics within your component. It will lead to a lack of clear responsibilities. So we'll not know which component is responsible for what. And the fourth issue is the redundant re-renders. The socket event handling inside this chat component might cause unnecessary re-renders and which will lead to a performance issues, okay? So maybe our app is small at the moment because this is a demonstration, but in real time, your chat applications are much more complex. And if you have this event of socket running on the top parent of your components, then you will have a lot of issues of performance running only because the child components have to re-render. You can notice how everything is happening inside our chat components. It's handling the UI, the socket logic, and the state management as well, all in one place. And this can quickly become a nightmare to maintain, especially as the app grows. Now, let's refactor this into something more manageable. And we are going to break it down into chat window component for displaying messages, a message input component for sending the messages, and a socket provider. Okay, so we will add a socket provider to handle all the socket logic for us, and we will use the context API to manage the state and communication between these components. Let's create our socket context. So I'll go inside app, I'll create a new folder called context, and then I'll create a new file which is socket context.js. And right here, all what I will do, I'll just paste some code, because this video again is not about how creating a context or using context API. If you are new to this, please feel free to watch my video about context API. But what I will do, I'll go through this quickly. So all what we are doing is that we are importing context from React, okay? And we are creating our context. It's like we are creating this bucket which will hold some information for us, and then we will wrap our components with this bucket so they can access all the information inside the context API, okay? Then we are defining our socket provider. And this socket provider will be the parent wrapper around all our components. And in here, we're creating internal state, okay, for messages. And then we are defining the sockets because we'll be using the socket here. And then we are defining these functions, okay? Send message function, and all what it does, it takes the text which the user writes, okay? And create a new message with an ID and the text, and then append that or add it to our message state. And then we are emitting a socket with a send message, and we are adding the new message to it. Accessing this function using context API directly from our input component. We don't have to do any prop dealing to access it. The next thing here is we have a use effect. Okay, and the use effect, what it does, it just emit the receive message, okay, for our new messages, and it makes sure it turns off the socket whenever this receive message is triggered, and the whole use effect is triggering every time this socket being triggered. Okay, why we're doing that? So whenever the user writes something in the input field and hit send button, I want my component to re-enter so it pick up the new messages. Okay, so that will happen, of course, whenever this socket is being triggered, and that's why we are listening to that in the use effect. Okay, and then we are accessing the socket context we created right there, and you do dot provider, so you have that wrapper bucket ready for you, and it accepts a property value by default, and then you give here whatever elements you want to access from your child components. So I know I want to access the messages because I want to display them on the UI, and I want to access this function because that will be the one triggering when I hit the send button. Okay, and then here you have your child component. And now here in the line 33, all we're doing is that we are defining a custom hook that we are creating that will help us to access this context that we created from our child component, okay? Without have to rewrite some code again and again. Again, if this is really overwhelming and you feel it's too much for you, feel free to watch the depth tutorial I created about the context API and the custom hook. And now what I will do here, I will do a small change and I want you to see me doing it so I can explain it for you. So what we are trying to do here is that we are trying to access the context we created because we need to access it from our child component so we can access the message directly from there. And same for my message input. I don't want to have this on send on the prop, okay? That's why we're doing the whole change. I want it to access directly from my context. So what I want to do, this chat window, a component, and the message input, I want to enforce them that to be only used within this context, okay? They have to be child of this context all the time to be able to be used. So in here, I'll define a const. I'll create context as an equal. Then I'm assign this context that I created up there. Okay. Then if by mistake, if someone try to access the child component from somewhere else other than the chat component, which is wrapped within our context, I want to give an error because this context will not exist if they try to do so. So I'll add an error here. I'll say if context doesn't exist, I'll just throw an error, new error, and we can pass here any message you like. What we say is that socket context must be used within the chat components, for example. Okay, you can add any message you want, and then here, if the context exists, then I'll just make it available for me. Great. So here, this is your custom hook to access your socket context within your child components. Okay, so it helps you keeping track of the changes we are doing. So, and here we created your context to handle state management and sockets. And I'll just fix my spellings, handle and management. Great, okay. So I hope this makes sense. So firstly, we created this context, our bucket. All our state will be there and handling all the socket calls will be all done there. So all that messy things, which is the logic of your component, will be moved right here. Then after that, we created a custom hook that will help us access all these details in our bucket, okay? So our child components, they don't have to manually go every time and access by themselves, but we create a function they can just trigger, which is our custom hook, and have the details ready for them, okay? Now, this is great. Now let's go back to our chat component. And what I will do, I'll import the custom hook we created. Okay, so use socket. Let me make sure that I export it here. Yeah, use socket. So I need to be inside a curly bracket from, oops, from, and let's access it from our context slash socket context, okay? Usually the custom hooks have to be in a separate file, but just to keep it simple for you today, I'm keeping it in the same file as my context file, okay? Now, we imported our use socket. Now we can access whatever we want. For the chat window, we only need to access the messages. So I'll come right inside my component here. I'll say const, okay, and the value or the name I will give it is messages. So I'll say messages, okay, equal use socket, and I'll save that. Okay, now this is complaining because it says it have a type of any, and I can fix it. And what I can do, I define the type of message here. So I'll just import it again. I think by mistake I removed it from my chat component. Okay, and then this one I can say type of message. Okay, now all is happy. I can go back to my chat component and I will remove this because we're not passing prop anymore. Next thing, I will go to the message input and I will have to do again the same things as well. Okay, so I'll come right here, import my custom hook, import use socket. Oops, use socket. And we can come right here. We don't need this prop to be passed anymore as well. And I'll come right here. I'll access whatever values I need to access. So I think for this component also we just need to access not only the function, okay, which is send message. So I'll just copy that to avoid any spelling mistakes. And I'll say equal to use socket. Great. Now, few other changes we have to do is here. So we have to replace this one with the one we imported from our custom hook. So send message, and that should be, that's it. Easy peasy. Okay. Now we can go back to our chat components and we remove this lane as well. Now we are done with refactoring our child components, but still we didn't do one thing. So the child components, they are trying to access our context, right? In like here, but we said that these child comps have to be wrapped within this bucket, okay? So we didn't do yet. And that's where we created this socket provider. So we have to go to our chat component and wrap these with that socket provider. So I'll go right here, I'll say import socket provider, okay, and we'll import it. And then I'll come right here and I'll just wrap my child component within my socket provider. Oops. So I'll just do move this child components inside. Okay. And now this looks great and much better than before. So we have to do some refactoring also. So we don't need all these things now. We can just remove them. It's all done within my socket provider. I don't need this one here as well. And I don't need this. I don't need that. Amazing. You can see now your chat component, it's much cleaner and much better to read. And all that detangled logic has been moved out, and our component only is doing what it has to do, which is rendering your child component. That's it. Now let's go back to our UI and test if this is still working. I'll hard refresh to be sure. I'm saying hi. Click send. There we go. It's still working. I am a coder. There we go. It's working. Let's do some a quick recap. Okay, so what we have done is we created the socket context, okay, where we moved the socket logic into this separate file using context API. Okay, and this keeps the socket management and the message state as well isolated from our UI components. The socket provider that we created right there, okay, wraps the application and provide the messages and send messages functions to any components that need them through the context. And the use socket that we created right there, which is our custom hook, is created so it's easily access this socket context within our components. Now, the decoupling components, the chat window and the message components, so the child components right here, are no longer relying on the prop drilling. Instead, they consume the socket, okay, like here we're doing line 5, directly using this use socket hook. So this decouples the components, making them more reusable and easier to test as well, which is amazing. The next thing is that the separation of concern. The refactored code now separates the socket logic from our UI, and you can see it clearly here. Your chat component now is much cleaner and much more readable. There is no logic here regarding any sockets or regarding any state. Okay, so the refactored code now and the UI components, chat window, and the message input are now purely responsible for rendering and interacting with the user, while the socket provider now we created right there handles the real-time communication for our application. The next thing is that we improve the reusability and maintainability. So the chat window component and the message input, okay, are now purely responsible for rendering and interacting with the user, while the socket provider handles the real-time communications. The next thing, the improved reusability and maintainability. So the chat window and the message input components are now can be used in other parts of the application or even in different projects with a minimal modification. The code is easier to maintain as each component has a clear and focused responsibility, which is more displayed in the UI. Now that we have refactored the code, here are some tips to keep in mind, okay? So first, always try to separate the concerns in your components. Let each component handle a specific responsibilities. Second, using the context API can help you avoid prop drilling and make your code more modular. And finally, when you are building complex UIs, consider breaking them down into a smaller components like we did right here. Now, you may run into some common issues implementing this pattern. One is handling state management between the components, okay? Especially with real-time data like chat messages. If you notice that your components are re-rendering too often, double check your use of context API, okay? Right here. And make sure you are not intentionally causing unnecessary updates. And also be careful with the dependency array, like we have here in lane 25, and make sure the use effect is having whatever dependency is needed and it's avoiding the infinite loops. You don't want to fall in that, okay? Now, to conclude this video and to wrap up, we have taken a messy, tightly coupled chat application. We refactored into a clean, maintainable structure using compound components. We have separated the logic, improved the organization, and made our code easier to extend in the future. Have you ever wondered how to handle a never-ending loop of nested comments or lists in React? Like when a comment has replies and those replies have replies too. It sounds tricky, right? Well, today we are going to crack that code with something called a recursive component. It's simpler than what it sounds, I promise. So what is exactly a recursive component? In a super simple terms, it is a component that calls itself. So imagine a mirror reflecting another mirror, and each mirror shows the other in an endless loop. A recursive component works the same way, letting us display things like nested comments without breaking a sweat. So let's dive in into the code and look at this example I'm having right here. So what we do have here is that a list of comments, and we are going to use a dummy data for this today video. And it is a list of comments, and each comment have an ID and a text, okay, the content of the comment. And some comments do have replies, and some others they don't have replies, okay. And this replies basically there's just array of comments again. And again, same thing, those comments, they can be just simple comments or they can be comments with replies as well. So this is where our recursive components will come into the play and help us to handle this scenario for us. So what I have done here, I just created a comment list component, okay? And that comment list will map through our comments data, okay? And then it will render for us the comment items. And this is where the magic should happen, okay? Because this comment item will accept these comments, and then it has to check that these comments, do they have any nested comments or they don't, okay? So let's go to our comment items and let's build it together. At this point, all what I have done, I'm just displaying the text because all the comments will have text. But then the next step is how to handle the nested components, okay? And when you're using recursive components, you need to be aware that always you need to have a stopper, okay? And a stopper means it's something that will stop your components from calling itself when it doesn't need to. And if you don't handle that scenario, then your components may end up in infinite loops, which is very scary and can crash your application. So for our demo today, it's very simple. So all what we have to do is first start checking if our comment does have replies in it, okay? So we will check if our comment does have reply, like this one doesn't have, but if it does, then this is the one we are checking for, okay? So if it does have reply, so let's do the following. We will have a div, and then inside we will map through our replies dot replies dot map, and we'll access the item inside our replies, which will be, for example, in this scenario, it will be this one, okay? And if we map to this one again, the replies here, it will be this one. So we are going to map to our reply. I'll call my item simply reply. You can call it anything you want, comments or anything you like. And we'll try to return something, okay? And this is where the magic will happen. What we will return is this component itself again. So comment item, and this comment item of course accept property of comment, which will give it this reply right here that we are mapping into it. Okay, oops, reply. And because we are mapping, you should be aware that you need to have a key, a unique key. And lucky for us, every comment have an ID which is unique. So I'll use that as a value for my key. So what we are doing here basically is that, like in our scenario now, first it map, okay, and it's going to render my comment item. Then my comment item, when it is in the first item, it does check does it have replies. And on this scenario we do, okay. So it goes again and return the comment item right there. And when it does in our scenario, it will have this one as a property passed on in the comment. And then it will render for us the text, simple, and then it will check again, does it have a replies? In our scenario, it does have replies. So it will go and return again that comment item here, okay? And this time, this comment item will have this one as a property passed on as a comment. And it will go again and render the text for us. And we check, do we have replies here? But we don't, right? So this is the stopper. It will just stop right there and will not try to do any other nested rendering. Okay? In the same level it was here, it mapped through this one and rendered the text. It checked does it have replies. It does not, so it just stopped right there as well. Very simple, very amazing. Okay, now let's go and check our UI. There we go. Okay, so if I put this one next to my code, you can see that is the first comment, okay, right there. And this is the first comment. Then it have a nested one. This is a reply, okay. And then another nested one, which is also this is a nested reply. And the same level of this one, we have this is the second comment. So here where the magic happens. So we are making this component called component item. It takes a comment and display it. But if that comment has replies, comment item will call itself to display those replies. This is recursion in action. The component keeps repeating itself for each nested reply. So with this recursive components, you can easily handle any level of nested comments without writing any complex code. And there you are, you have it. With just a few lines of code, we have created a powerful recursive component that can handle any level of nested comments. It may seem tricky at first, but when you have seen it in action, it's super cool and really useful. Give it a try in your project and see how it works. Hi everyone, welcome back to my channel. Today we are diving into this magnificent world of higher order components or HOCs in React. We will be using TypeScript and please don't skim at the screen if you are not comfortable with it. It is again just JavaScript, so I'll keep it very simple and I will tell you the difference whenever it's needed. Okay? So we'll be using TypeScript to make our code type safe and also use Tailwind just to help me quickly add in some styles, okay? So if you are new to this concept, please don't worry, I'll break it down step by step. So first things first, what is a higher order component? In simple terms, an HOC is a function that takes a component and return a new component. Think of it like wrapping a present. The gift inside is your component, and the wrapping paper is the extra features or functionalities you're adding with the HOC. Simple as that. So HOCs are very super handy, and when you want to reuse some common logic across multiple components without repeating yourself. So imagine you have several components that needs to log some data whenever they are clicked. Instead of adding the login logic to each component, you can create an HOC that does it for you, that keeps your code dry, don't repeat yourself, and easy to manage. But before we dive into the code, let's talk about the project structure and keeping our file organized as it is crucial for maintaining a clean and scalable code base. Okay, so we will go first right here. I will create a component folder. And inside my component folder, I will add a new folder which is called HOCs. And the HOC I will create will go just under there. So for today's demo, I'll be creating a button component and I want to add an HOC that will help me to add effects to my buttons whenever it's needed. Okay, so first things first is that I need to create my component, which is the button itself. Okay, so I'll come right here, I'll call it button. and I'll create my component itself. Okay, and my component basically to be very simple one. I'll just call it button, and it will accept a property right here, which is the text. Okay, so this I need to add the type, and this you don't need to do it if you're using JavaScript. So I'm just enforcing the type of my components. I'm saying it is a functional component in React, and it accepts a property of text with type of string. Okay, now we'll come right here inside, and what I will do, I will just add some styling using Tailwind CSS. And don't worry about if you don't understand what it does really, it's just for styling purpose. So I'm just adding some paddings on the right and the left, and padding on the top and the bottom, and the text will be white and the background will be blue, and it will have a rounded corners with 4 pixels on all the corners. Okay, and then inside here I just want to display the text, and of course I'm returning my button. Now here I define this button component, and I need to create this HOC that I will call it with hover effect. Okay, and this HOC, what will do for me, it will add up some hover effect to the buttons whenever I need them. Okay, so what I will do, I'll just go inside my HOC. I'll create a new file called with hover effect. Okay, .tsx. Okay, and if you're using JavaScript, it will be GSX, of course. What I'll do, I'll just import, of course, React from React. Okay, and then I will define my HOC. Oops, go back right there. Define my component, so with hover effect. And the next thing I will do, this is just in TypeScript. Okay, so I need to add a type called p extends object. So basically what I'm saying, oops, it adds something extra for me, which I don't need. So all what I'm saying is that this p generic type will ensure that my HOC can work with any component that I'm passing as a prop, okay? So if you remember what I said before, your HOC, it takes a component as a property and then return you a new version of it. So I have to enforce this type, so it makes sure that my HOC accept any type of components. Then my component will accept, as I said, a component. I'll call it wrapped components. Okay, and that will be, of course, of type of React dot component. Okay, what that enforce component, I should say type, and this is again just TypeScript related. If you're using JavaScript only, you don't have to do it. Oops, it add this extra thing. So remove it. So all I'm saying is that my with hover effect will accept this wrapped component as a property, and this wrapped component will be of type React component type and this generic type of P. Okay, that's I added right there. Now, this of course will return you back a component, so say return and props. So whatever props are within the components that I had, I'll return them back. And I will add now return whatever extra things I want to do. Okay, so my HOC, I just want to use it to add some extra effect on my hover. So what I will do, I will just paste this code quickly right here. And obviously I forgot my arrow function. Okay, so all what we have said here is that I need to fix this too. So all what we're doing here is that we defined our HOC, it accepts a component, and all what I'm doing is that I'm returning my component again, but just wrapped with extra div at the moment, that I'm adding some animation. So I'm having hover, so I'm scaling this, making it bigger, and then I'm adding the transition and transformation that I want. Okay, then I'll come right down here. I'll say export default, and I'll say with hover effect. Great. Now we created our HOC. Let's go back to our page. And what we'll do, I'll import my button, import button from components, and then also I will import with hover effect as well. Okay, and what we can do, I'll come right here and I will define a hover button. Okay, const hover button, and I will say this button will be my button. Okay, but it will be wrapped within that HOC I created. Okay, so with hover effect. Now I can come inside right here. I will first thing just display my button alone, and then I will display my hover button as well. And you can see it's complaining because the TypeScript, so it knows I need to pass a text, or just say just simple button. And next one here as well, because even my component it's wrapped within an HOC, because I'm using TypeScript enforcing type, it knows as well still that I need to pass the text. So I'll just say text equal enhanced button. Okay. Now what I will do, I'll go back to my UI 3000, and there you can see. So the first one here you can see I'm hovering, but nothing's happened. Unless we make it bigger. Okay, so I'm hovering, nothing's happened. But second one, when I hover, you can see it's scaling up. Okay, so there you have it. We just created this higher component in React using also TypeScript and Time CSS. The HOC are really powerful tools for making your code more reusable and easier to maintain. I hope this example made the concept clear and helped you to see how HOC can be used in your own project. If you enjoyed this video, please be sure to give it a thumbs up and subscribe for more tutorials like this. Thanks for watching, and I will see you in the next one. Hey everyone, did you know that over 70% of React developers use the provider pattern in their application? That's right. This pattern is essential for managing state and context, especially in complex applications. Today, we will not only dive into a more advanced example using the provider pattern, but we'll also set up a professional folder structure, use TypeScript, and again, please don't skim at the screen. TypeScript again is just JavaScript, and I'll keep it very simple. So I'm using TypeScript for strong typing and style our components with time in CSS. Ready to build it like a pro? Let's get started. Before we dive into the code, let's quickly recap what the provider pattern is. In React, this pattern helps us manage state across multiple components without passing props down through every single one, what we call prop drilling. Instead, we use a provider to make the state available to any component that needs it. Okay. Now, when we are working on larger projects, having a clean and organized folder structure is very crucial, and this is the way we are going to do it. So I will go and create a components folder, okay, and I will create a context folder. So the component folder will hold all my components, and the context folder will hold the context for me that I'll be creating. And I'll add one more folder, which is for types. Great. Now, let's start writing some code. So first thing, because I'm using TypeScript, I need this types folder to put my types in. So what I will do, I'll create a new file which called user.ts. Okay, so I need to be centralized because I will need this interface or this type in many files in my project. So I want to place it in one file and make it available. So export interface, and I will call it user. And usually I just add I in the end, so I have understanding the difference between an actual component I'm exporting and actual interface I'm exporting. So the user will have an ID, which should be of type number, and we'll have, of course, the name of my user, and it will be type of string. And also I want to have an email as well. and that will be type of string. Great. Now we have done with our types. Let's go and create our context, which will handle my user state and details and make it available for me to all other components. So what I will do, I will go inside my context. I'll create a new file which called user context. Again, you can call these files anything you like, but it is recommended to keep this context keyword in your namings, so when you're importing them and using them, it makes sense for you what is that file for. So, first thing we'll start doing is importing React. And then also I need to import create context from React as well, which will help me to create my context. Again, if you're not familiar with context and context API, I have full video detailed and explain exactly what is context API in React. Okay, now I'm importing create context from React, which helped me to create my context, which is this bucket, will hold all the details and informations for me that I will need later in other parts of my application. And I will need to use context, which helped me to consume this context I created. And inside my context, I will need a state, so I'll use state, okay? And I will come down here now and import my type I created before, which is user I. And now I'll come here, and what I will do is that I will start creating my context. So first I'll say const, and I'll call it user context. So a meaningful name, it will be create context. And because I'm using TypeScript, I need to give it a type, okay? And if you're using JavaScript, you don't need to do this. So I need to define basically a type. So I'll come right here. I'll call interface, and I'll call it user context type, for example. And I would expect to have a user, which should be of type user or null. And you have to do this or null because, sorry, this one is user I. And you have to do the null because the first time when you're running your context, you're creating it, it will not have anything in it. So you have to manage that that scenario as well, okay? And I will need also a function that I'll need later also in my context. So I'll define that as well, which is called set user, which will help me to set up my user details. And that will be react dot dispatch. Okay, again here I'm just defining the type, and to have type react dot set state action. Okay, and it will be setting the type user I or not. And don't worry if this is overwhelming. As we start creating our context, it will make much more sense to you. And I will close this as well. Now I'll come back here and pass this type. So my context or the bucket I'm creating, it will be with this type, and this is the things it will have inside, okay? Or it will be undefined, and again, because first time we're creating this bucket, we are creating the bucket to be empty, it will not have anything, okay? And I'm passing by default undefined. Nice. So now I created my bucket. Let's create my provider, which will make this bucket available for me to my application. So export const, I'll call it user provider. You can call again anything you want. And this will be of type React. Again, if you're using JavaScript, you don't have to do this. So React functional component, and it will accept an argument, or it will accept some props, and the prop will be children by default, which will be the children components we are passing, and this children of course is type of react dot react node. Okay, so it will be type of react, it will be a component. I will close this, and here I just lost a C, so I have to edit it right there. Okay, and we will be saying this is equal, and of course I have to define the props I'm passing, which will be children, and then let's have our return. So inside, I'll define the state I need. So I need a state of user, okay, and set user, which help me to set the user details, and that will be coming from our use state, okay. And the use state will be of type. Again, if you're using JavaScript, you don't need it to do this type. So type of user, oops, user I or none, and the default value we'll have at the start is a null. Great. Now we come to our return. So what we'll be returning? So what will be returning this user context that we created, which is our bucket here, okay? And we can access something called provider. And inside this provider, it have a property called value. And this value, basically, you can pass anything that you want your child components to have access to, okay? In my child components, I want to have access to both user, my user details, and also the setup function I have right there, okay? So I'll make them both available to my child components. And inside, of course, we'll be displaying our children. Children. Me and my spellings. Okay, that's the children. And here is complaint saying, I can't find it. You mean, oh, I did another spelling somewhere. Damn it. Here we go. Children. Good. So we created our bucket. We create the provider that will make this bucket available to us. Now, next thing is I'll create a hook. Okay, and usually we do this one also in separate file. So what I will do actually, I'll create a new folder which called hooks, and inside there I will create my hook, which is use, and always your hook starts with use keyword, and also use user dot ts. And here what I will do, I'll just export const, okay, I'll say use user, and it doesn't accept any props. Oops, here you need equal. And what I will do, I need to import the context. So I have to go on the top. Oops. Next. Okay. So I can use the context I created. And down here, I have to import the user context that I created. One moment. Let me see. Oh, I didn't make it available, so I have to make it available to my project. So I have to do export here. Good. So I'll come here. I'll say user context. And what I will do inside my hook right here, I will just go and create an instance called const context. You can call it anything you like. And then I will say use context. And I'll be using the context I created, which is user context. Okay. Now, I want to do some check here, okay? So if someone try to access this context outside of this provider, that context will not exist, okay? So I have to handle that. So I will say if context does not exist, then throw some error. You can do any error management you want, or what I will do for me now, just throw an error. I'll say use user must be used within a user provider. Okay, otherwise I'm just returning my context. Okay, very nice. So up to now what we have done is that we created our user context and the user provider, and notice how we also included this custom hook, which is the use user. So it makes it for us easy to consume this context in our actual components. Okay, now let's go and actually start creating these components. So I want to have a dashboard, a user dashboard. So I want to have a section which called profile and another section which calls settings. Okay, so what I will do, I'll go inside here, I'll call a folder called profile, and I'll create my component there, which called index.tsx. Okay, and what I will do here, I will import React from React, of course, and then I'll import my hook that I created here. Okay, so import my user hook. Great. Now let's create our component. So const profile, and that will be of type react.fc, so functional component. It doesn't accept any props, and because we are using this context API to avoid any props trailing, so it have access actually immediately to your context. So we can do const and we say user equal user. Okay, and this user is the one we make it available right there. Okay, in this we pass to the value, so that's the name we are from where we are getting this user. So that's how you can access your context. And then in the return, I'll just paste some code very quickly so you don't see me typing boring things. So all what we are doing here, basically we are checking the user. If it does exist, then I'm displaying the name, the email, and then if it doesn't exist, I'm just saying no user data is available. Good. Now let's create the settings. We'll call settings, and I'll create my comp X. Okay, now these settings will be a little bit different, and here we'll be setting up our user. Okay, so what I will do, I just quickly paste some code here. This part is wrong, so I'll just fix that, and I'll say context slash user context. Okay, and actually I will have to delete that lane because I create a different folder for the hook. So I'll say import use user from my hook folder. Okay, so what I did basically here, I created a component which called settings, and all what it does for me is that it displays a title, then it has a button. Okay, and that button, it says update user details, and when you click it, it triggers a function. And this function at the moment, we don't have any forms because it's not the purpose of this video, so I'm just mocking the details. So whenever you click this update user, we are triggering the set user right here that is coming from our hook, which is coming from our context provider from this lane here. Okay, and this is the way we make it available for us. So whenever someone click that button, we're just updating the user details. So the assumption is when you do that, you should see this updated details in the other component, which is accessing the user details. Okay. Now this is good. So we created our profile component, we created our settings component. Now it's time to put all these things together and assemble them. So we will go to the entry page, which is my page.csx. Because I'm using Next.js, I'll remove all this stuff from here. And all what I will do is I will just import this component that I created. So import profile. Let's go back to our page. So I imported my components, but I missed one huge step here. Okay, so I have to wrap these two with that provider we created in our context. So let me close this. So this provider. So I have to import that provider as well. And make sure your components are wrapped within that provider. Otherwise, your context will not work. And we can actually try to give it a run and see what error we will get right there. We say Can I tackle the presentational and container component design pattern in just one video? Let's find out. This pattern is a key concept in React, helping us write cleaner, more scalable code. So today we are diving deep into this pattern to show you how it can seriously level up your React skills. So let's get. So have you ever started building a React app, adding cool features, only to find that your components become more and more tangled? They end up doing everything, managing the state, handling API calls, and rendering your UI. It gets messy, right? So suddenly, one small change breaks everything, and your components are almost impossible to test. So that's when you know it is time for a better way to manage your components. So this is where the presentational and container component design pattern shines. It's all about separating concerns, keeping your components simple and focused on one thing. Presentational components, these are your dump components. They just render the UI, receiving data via props, no state, no logic, just a beautiful reusable UI. Container components, these are the smart ones. They handle business logic, making API calls, and manage the state. They pass the data down to the presentational components. And before we dive into the code, let's look at how we structure this pattern in a professional way. So we will have our components folder, which will hold a user list folder and users container folder. So the user container folder, from its name, you will know that is your container component, which means it will handle the logic and passing the data down. And the user list folder, that will be the dump component, which will just render the UI for us. Now, let's start with a presentational component. This is where TypeScript and Tailwind CSS come in for that clean, scalable code. So first thing is go to the app folder and I'll create a component folder. And inside, I'll create a new folder which is called user list. And inside, I'll just add a new file which is called user list. And I'll be using TypeScript. And again, if you're not familiar with TypeScript, don't worry. It's again just JavaScript with a little bit extra type restrictions we are adding to our component. So don't scream at the screen. It's also simple. If you're using JavaScript, just add JSX as extension instead of TSX. And whenever we write some typing interface, you don't need to do that. So let's create our component. And let's first thing, because I'm using TypeScript, I need to add a declaration of type. And I will call it user list props, and always add I in the end. It just helps me to know what is the difference between actual component and actual interface if I have to import it somewhere else. So I will be rendering list of users. So basically I will accept to have a users coming down to my component, and this user will be an array of objects. Okay, and this object for my example today will just have an ID, which will be type of number, and it will have a username which will be type of string. That's all, very simple. Okay, now let's create our component. So export const user list. I'll call my component user list, and that will be type of react.functional component. And again, if you're using just JavaScript, you don't need to do that. And it will be expecting props of type user list prop that we declared up there. And then here we'll say equal, and then we'll pass the prop it is expecting, which is our users list, and then that will be an arrow function. Now we'll be returning a very simple UI, so a list UL, and I will add some classes using Tailwind CSS just to help me to have some basic styling without have to write any CSS code for it. So I'll call it list slash dash disk, and then I'll add some padding on the left. I'll call it padding PL5, so to add some padding on the left of 20 pixels. Okay, now inside here, inside our list, now we'll just map through our users and render a list of the users. Okay, so we'll just display the usernames. So we will say users dot map, okay, and it will accept parameter of user. So that is the element in your array, so you can call this anything you like. And then let's render our UI, so our list, so it will be allies. And of course, when you're mapping, you have to add a key all the time in the first parent element within your mapping. So the ally is the top, so I have to add a key, and it needs to be unique. So I know the users have ID, so I'll use that. So user ID. And then I'll just add some class again for styling. I'll just use some built-in classes in Tailwind. So I'm just keeping text as a blue. And then inside, I'll just display my user.name. And that's it. So basically, oh, not name. So you can see here, because I'm using TypeScript, complaint, it says there is no property of name, but it is a user name right there. And actually, even the name here, I'll keep it lowercase, and I'll use the same parameter name I'm using. So this is good. So this component basically is a purely presentational. It receives a list of users as a prop and renders them with some nice styling from Tailwind CSS. That is it. No state, no logic, simple, right? Now, we need a container component that will handle that heavy lifting, like fetching data or managing state. Now, let's go back to our component folder, and I'll create a new folder which is called, for example, user container, and I'll create my component there. So I'll call it user container.tsx. Again, if you're using JavaScript, you just do JSX, and I'll enter right there. So first thing I need to do is I will need to declare my component. So I'll just say export const. I'll call user container, and that will be type of React dot functional component. Okay, and we don't have any no props for it, so no props are there, no definition for their types as well. Now I want to render here a list of users, and I want to fetch that list of users from somewhere. Okay, basically that means I will need to import use state from React, and also I need to import use effect as well. That's where I will fetch my API call. And this is a standard ways. Again, I'm not trying to teach you other patterns. I already have other videos. So today I'm just focusing about what is the container and the presentational components. Okay, so use state, we need to store the data somewhere. So we use a state to store it, and use effect will handle the fetch of the API call. So we make sure we are calling the API when the component's about to render. Okay, now we come here, say const, and I'll say users, and I'll say set users use state, and I will say, okay, the use state, we will be storing here list of users. Okay, so we have to tell, because we're using TypeScript, what type of data we are storing. So again, same thing we did in previous screen, you need an array of objects, that's the thing we'll be storing, with ID of number and username of type string. Okay, okay, and then we'll give a default value right here, which will be an empty array to start with, because we don't have any data yet. Now next thing is that we need to run our use effect. Okay, and we want that one to run only our first time the component is mounted, and that's mean I'll add just an empty array as a dependency right here, so it's only run the first time. Okay, and let's say for example we have some API and we are using a method to call it. Let's say call fetch users. Users. And what I will do, I will just come and define the users just function right here. Okay, so this user, basically we are mocking now the data. So usually is, for example, be some API call running, but we are not doing that for this video because we're just learning about this pattern and not about how to fetch API calls. So we're just mocking it right here. And when you get usually your data back, that's when you set it back in your state, and you use the set user that you're getting back from your state to help you set that data back in this state users right here. Okay, great. So up to now it's very simple and easy. Now to the thing why we are using this as a container. So we have a return function. We will return our UI, and what we say, okay, I'll add some styling. Again, I'm just using Taiwan CSS. I don't want to see me typing all these boring things. Or what I'm doing is that I'm having a div which have some style, then add titles and user list, and this is where things happen. So we have the user list component. Okay, so we'll come here and import our child component. We call it user list components, and we import it right here. Okay, and I think I have some spelling mistake, so I'll just do like that. And if you remember, we said we expect a property called users, so we pass that users right there, and we give it back our state where we stored our data that we assuming we fetch from an API call. Okay, so let's save this and let's go back actually to our UI. So as our UI run, we can see that is the title, the user list, and we have list of our users. So this user container is in charge now of fetching your user data and also managing it in the component state. Then it passed the data down to our user list presentational component to display. So with TypeScript ensuring strong typing and Taiwan CSS that handle the size, it's both a powerful and a clean way. Now, so why you will use this pattern or why this pattern matters? So by separating the logic, you have the container component from the presentational component. We get a few big wins. First thing is a cleaner code. So each component has a clear purpose, making it easier to read and understand. So we can go here, for example, first thing your code is short, and you can see, oh, this component basically all what it does is fetching some data and passing it down. And if you go and read this component, it's again very easy and simple to read, right? And you say, okay, this comp all what it does is that it's expecting a property or a prop, and all what it does is just map through it and just render it. Very nice, right? So other thing also to give us is better testing. So if you're a big fan of testing, we should be, to be honest, we can test our presentational components separately from the logic-heavy container components, which make your testing really much easier. And reusability, which need the UI somewhere else. So let's say, for example, you need this list somewhere else. So you can just grab this presentational component and reuse it without any worry about the data that is rendering. So this is a very classic pattern that still holds up in modern React apps, especially in more complex projects in real time. So, and there you have it. By splitting this component into presentational and container component, you can make your React code more maintainable and scalable. And if you have struggled with tangled components in the past, give this pattern a try. It may just save you a ton of headaches down the line. So what do you think? Have you used this pattern before? Let me know in the comment section below. And if this helped, be sure to like, subscribe, and check out more React tips on my channel. So, see you in the next one. Hey everyone, welcome back to my channel. Today we are going to explore a super useful pattern in React called the builder design pattern. So if you have ever found yourself managing complex objects in React, this pattern will help you to make that process so much easier. I will walk you through it step by step using TypeScript. And don't worry if you are not familiar with TypeScript, JavaScript also will be just fine. And by end, you will understand how to apply this to your own project. So let's get started. All right. So what exactly is the builder design pattern? So imagine you want to build something complex like a house or a pizza. You can't just do everything in one go. You need to follow steps. The builder design pattern lets you build things step by step and customize them along the way. It helps us manage complex objects, separating how we build them from what we are building. So this pattern is super useful when you are dealing with complex React components. For example, think about forms with different sections or configurations for dashboards. Instead of building everything in one giant function, the builder design pattern lets you build each part separately, making your code more flexible and reusable. Plus, if you want to create a different version of the object, you can just tweak a few steps without changing everything. So let's dive into a real world example to make this crystal clear. We are going to build a pizza step by step using TypeScript. Are you ready? So let's go. First thing what I will do, I'll create a component. So I'll do a components folder, then I'll create a folder called pizza maker, for example. And then I'll just create my components under that. So first thing, of course, we need to create our components. I'll create one using my Visual Studio Code, and I'll call it pizza maker. Great. Now, I defined my components. I want to initialize the state for the pizza with empty values. Okay, so first thing, of course, we need to import use state. And with new React, you don't have to keep importing React, but if you want to do it, feel free to do it. So I'll come inside my functional component. I'll just initialize my state here, and I'll create a state called pizza. And then I set a function, of course, which called setPizza, and that will be equal to use state. Okay, so we're creating our local state, our local store. Okay, now this state will accept a default values. So for example, let's say I want a layer of crust. Okay, and let's add something called sauce, and let's add something called cheese, and let's say also toppings, and that will be an array. Oops. And of course, because we're using TypeScript, I need to define a type for my state. So I'll just paste it right here, and I'll call it pizza I for pizza interface. And then I'll pass that type to my use state. And of course, we're using JavaScript. You don't have to do that at all. Oops. So I'll just call it pizza I. Okay, so now everything is happy. Now next thing we want to do is construct or build our pizza, right? So we'll say we take these things step by step. So the first step, for example, is adding the crust. Okay, so I created a function called add crust, so it's only handled the crust addition to my pizza. And all what it does is that it pick up my current state. Okay, so we're using the setup function, pick up current state. So whatever values are there, keep it, and only change the type of my crust, okay, which we are passing that as a property for our function. So this one, all what it does is just a build the crust section for us, okay. Now same thing we will do for others as well, okay. So we'll create again another function which handle for us only the sauce, okay. So whatever changes, that function will only handle the sauce change only, okay. So what sauce, for example, you want to add to your pizza. Now, next thing again, we'll do same thing now for others. I think you got it now. Come right here and I'll add another step which is for cheese, and does also the same thing. It just pick up my state and build on top of it, keep the state whatever it is, and just change the cheese or the type of my cheese. Okay. Now same thing for our topping as well. So we'll come right here, and all what you will do as well is just change the toppings in my state. But whatever my previous state, just keep it as it is and don't change it. Okay. Now, after building, we can return the complete pizza to, for example, a pizza display function. Okay. So what I will do before I build the UI here, I'll add another component which call pizza display. Okay, and I'll create my component index.tsx, generate my component, call it pizza display, Okay, and this basically will just display my pizza. Okay, so of course you'll accept a property here which called pizza. That's our pass from the parent component, and that pizza will be of type pizza, of type pizza I, or whatever interface actually we made on top here. So I'll export this and I'll just import it from my other file. So just import it right there. Okay, so all what we are saying is that this display pizza will just display for me the pizza, and we are getting this property from the parent component, and it is of this type right here. Okay, now in the UI again it's very simple. All what we will do is just display the details of our pizza, and my mouse is just not helping me out today, so let's just select this and paste that. So always we're saying this is your pizza, this is your crust, this is your sauce, and these the list of your toppings, and that's your cheese basically. Okay, simple as that. Now we come right down here to our return function, and all what I will do now is just import my child component and just pass the details to it basically. Okay, and I add few buttons there as well, so I need to import this. So all what I done here is now is just after we build it, now we have to return this completed pizza to our pizza display component, and I added few buttons right here, and I don't know why this add sauce is complaining. Basically I just forgot some curly bracket in my code, so now it's all good. So all what I have done here, basically I just added 4 buttons, and in my buttons basically I'm just adding the ingredients. Okay, so each button will handle for me one ingredient, one to add the crust, one to add tomato sauce, and another one to add mozzarella, and other one to add the pepperoni as my topping to the list. Okay, then I'm displaying my components, and now let's see how this will work. And this how it look like, and I don't think it looks pretty good, so give me a moment. I'll just put some styles here. So I'll just go down right here, and all what I will do is exactly same thing with some styling. Okay, so all I'm doing, I'm just using Taiwan CSS to help me add some basic styling so our UI looks more friendly. And same thing I will do for my pizza display as well. I'll just add some styling there as well. And let's go back to our UI, and this is much better and much cleaner to the eyes. Now, of course, let's try and see if our UI is working. So I'll just add a thin crust to my pizza. You can see that's working. Let's add tomato sauce, let's add mozzarella, and let's add some topping as well. So this will give you a good idea, right? So this why this pattern is called a build-up pattern. You can actually, with the same function, you can make it dynamic and build as many pizzas you want, okay? Whatever you like. And same thing, for example, if you're building a home. So now let's go over this again. So what we have done basically now is that we use TypeScript state. First, we define the pizza up here in our lane 15, and specify that our pizza will have a crust, a sauce, and cheese and topping. Okay, and the topping is this array of strings. Then we use the use state with TypeScript. So we use the use state hook to store the pizza state. In TypeScript, we define that the state must follow the structure of our pizza type that we defined in lane 6. Then we create functions. So we have 4 functions right here: add crust, add sauce, and add cheese, and add toppings. Each one is responsible for updating a part of the pizza. So notice how we don't touch the whole pizza object at once. We just update one part at a time. And this keeps the logic organized. Then finally, we did the display in the pizza, which we passed the pizza object down to our child component pizza display, which shows the completed pizza with all those chosen options. So what is the big deal with all of this? Why we use the builder design pattern? So first things for flexibility. So imagine you want to create a different pizzas, maybe one with extra cheese or another one with gluten-free crust. The steps stay the same, but the details change. You don't have to rebuild everything from scratch. Then you have the reusability. So you can easily reuse these functions to build other customizations, like building a sandwich or creating a car with different parts or configuring a dashboard. You can follow the same process without writing a new code. Then you have the maintenance. If you ever need to add a new step like a special sauce, you can just add another function without breaking everything. So your code stays clean and easy to maintain as well. And to push this further, let's say you are building a car, you'll have steps like adding the engine, the wheels, the paint, and also the interior. By using the builder design pattern, you can easily mix and match the parts to create different versions of the car, a sport car, a family car, or even an electric car. That is the builder design pattern in a nutshell. It helps you build complex objects step by step, keeps your code flexible and reusable, and make it easy to maintain. You can use this pattern in many scenarios, from building pizzas to cars or even more advanced React components. So give it your try in your next project and see how much easier it makes things. So thanks for watching. If you found this helpful, please give it a thumbs up and subscribe to the channel for more tips on React and TypeScript. Hey everyone, welcome back to my channel. Today we are going to learn about the singleton design pattern in React, and we'll be using TypeScript. And if you're not familiar with TypeScript, don't worry, I'll make it simple. In the end, it's just a JavaScript. So it maybe sounds technical, but don't worry, I'll make it super easy to understand. And by the end, you will know how to use it in your own apps. Dive right in. First thing is, let's explain what the singleton design pattern is. It is a pattern that ensures only one instance of a class is created. So think of it like just one TV remote in your living room. If there were two, it will get confusing. You only need one instance to control everything. And that's what the singleton pattern does in code. In our app, we will use the singleton pattern to manage authentication. So imagine you have multiple login methods like Google, Apple, and Facebook. Instead of creating a new authentication system for each login method, you will create just one instance that can handle all of them. So let me show you how. In React, the singleton design pattern can help improve performance and organization. So let's say you have a component that handles different authentication methods like Google, Apple, or Facebook. You want to switch between these without creating a new authentication system every time. The singleton pattern ensures we only create this one authentication instance and reuse it. It is efficient and helps keep things neat. So now let's get our hands on with some code, and I'm giving you here a full example that you can follow along with. So we'll be creating an auth component right here to manage Google, Apple, and Facebook login methods. And we'll make sure we only have one instance using the singleton pattern. So first thing is that we need to create three simple components for login methods. So Apple auth, Facebook auth, and Google auth. We will create these components under our components folder, and at the moment they are very simple. Or what we are just displaying some message saying login with Apple and login with Facebook and login with Google. Now we'll go back to our auth components. And this is where the magic happens. We will use a singleton pattern to make sure we only have one instance of authentication handling all the login methods. So I created this component under my components folder. And what I will do right here, I'll just go and import, of course, the child components that I will need. So import Facebook auth, import Google auth, and import Apple auth as well. Okay, now let's create our singleton to ensure we only have instance of it. So I'll come right on the top of my component, and what I will do here, I will just create a singleton pattern to ensure only one one instance. Oh my god, man, my space, one instance. So we'll create a class called auth singleton, and you can call this anything you like. And what I will do here, declare a few things. So first I want to create a private static instance of my auth singleton. Okay, so whatever your class you named right there. The next thing is I'll create a public auth type, which should be of string. And then we will create here now a private constructor. Okay, so this one will help us to construct our class, and we'll say this dot auth type equal an empty string to start with. Okay, now we'll go out of here and let's get the singleton instance. Okay, so we have to handle that. So we'll create a static function called get instance. Okay, and that will be an instance of auth singleton. And then we will say, okay, if auth singleton dot instance does not exist, so we don't have any instance yet, then what we will do, we'll create a new instance. So we say auth singleton dot instance equal a new auth singleton. Okay, so basically we're just trying to create an instance of our singleton. Then we'll come after our if statement and we'll return that instance, of course. So auth singleton dot instance. Great. Okay, so up to here, nice. Now we'll come next after this and we'll say set up a setter function. So set the authentication type. Okay, so we need to know which type of authentication we are having. So it will be very simple. We'll create again a function called set auth type, and you can call this anything you like, and that accepts a parameter of type, and that type will be type of string. And what will do for us is set the auth type, so the type you are passing as a parameter, of course. Now next we need to have a function that will help us to get the auth type. So get auth type, and you can call again this one anything you like, and doesn't accept any parameter because we're just getting something back. So return this dot type auth type. Great, so we created our class now. Now I'll come right down here, and what I will do, this auth component will accept a property which will be of type auth type. So auth type, that is my prop name, and that will be of some type which I need to declare up here. So interface, and I'll say auth component props at I and end for interface, and that will have an auth type, so whatever your property name right here. So auth type, and that will be of type string. Again, if you're using JavaScript, you don't have to worry about all these interfaces. So I'm saying this auth type will be type of auth component props I. Oops, I forgot something, so it's not like that. Wait, so it should be here, two dots, so my whole props are of this type. Okay, and this one of course will be a React component. So that will be a React.aFunctional component. And I'll just remove this curly bracket. I don't know what I'm doing today. Okay, great. So what we have done is that we create a component. It accepts a property called auth type, and that will be of this type here. So our auth type will be of type string. Okay, so this one here is right there. That is the type of it. Now we go back to our component. So inside here, basically we need a local state that will hold for us the current authentication okay, or the kind of authentication type. So what we'll do, we'll use set or const. I'll say my current auth, and you can call this anything you like. And of course, we set a function, set current auth, and that will be equal to use state. And this use state will have a default value of null. And because I'm using TypeScript, I need to tell what is the type of my state. And I know it will be type of string or null. So string or null. Then now we need a place where we can set our authentication. And for that, we'll be using use effect. Okay, so we import, we'll import use effect. And we'll come down here and we'll say use effect. And that use effect, I will want it to run every time my auth type is changed. So I'll add that one in my dependency array. So that will make sure whatever code we write here, it will run every time this auth type changes. Okay, now I'll go inside and I will say const, and here I'll use my class. I'll say auth instance equal to my auth singleton class dot get instance. Okay, so I'm creating an instance for my class now. Then I'm going to set the type, so auth instance that dot set auth type, and we'll set it to whatever property coming down in my component. Nice. And then I'll set also my current state, my local state, my component. So set current with the updated type, so auth instance. Now we will get the type from our class instance itself. Great. So this code basically here in our use effect will run every time this auth type here changes. Okay. Now we can go inside our return function, and what we'll do some conditional rendering. So depending on the current type or auth type, we'll be rendering our components. Okay, so if current auth is Google, then we'll render this. If it's Apple, then that. If it's Facebook, we render the Facebook auth. Okay, and I can see the tricky lines here just because of my TypeScript. So I think what I will do, I remove the type interface of my props from here, and I'll come right here. I'll just do it right there, and that should fix it for me. And also one thing you can do, for example, I keep using react.fc for a type of my component. You can just import fc like we do for use effect from right here, and then you don't have to write react.fc, you can just write fc. Okay, and that's all for the type interface. Now that's what we have. Now that we have our singleton logic in place, let's see it in action, and let's create an auth async usage component that we use this auth component. Okay, so let's go back in our component folder, and what I will do, I'll create a new component which is called auth instance usage.tsx. Oops, .tsx. And what we will do here basically is very simple. We will just import the auth component that we created right there. And what I will do is export the default, so I don't need the curly brackets. And what we have is just a title, okay? And I'm passing that auth type as Google to the component, okay? Now let's save this, and what I will do, I'll just make sure I import this in my page.jsx. Just like that. Let's save it. Let's go back to our UI. You can see we have the title there, and then we have this one is actually the child component, which was Google auth.tsx rendering, saying login in with Google. Okay, so that was this component right there. Okay, so we can now easily just go to the parent and, for example, do here Apple, save it. We go back to our UI. And then you can see here the actual Apple authentication component, which is rendering right there. So that is it. We have successfully used the Singleton design pattern to manage our component authentication in React. So by using this pattern, we made sure that only one instance of this authentication has been created system, which helps keeps our app efficient and clean. So if this tutorial helped you, don't forget to hit that like button and subscribe to more easy to follow coding tutorials. Leave a comment if you have any questions and let me know what you would like to see next. Hey everyone, welcome back. Today I'm pumped to talk about something you have been asking for, which is how the factory design pattern works in real-world applications. This video is not just theory, so we are going to bring it to life in a scenario you will recognize, online shopping. So stick around and by the end you will see why the factory pattern is more than just a fancy code. This pattern is a lifesaver in a complex real-world applications. In the real life scenario, we'll have a customizable products and an e-commerce. So let's say you are building an e-commerce site for a client who sells laptops, cameras, and smartphones. Now, each of these product types have unique attributes. Laptop, for example, have a RAM, processors, and storage options. Smartphones comes with screen sizes, battery lives, and operating systems. For cameras, include megapixels, lens compatibility, and sensor type. With these specific needs, we want to build a scalable, flexible structure that's ready to adapt if the client expands to a new product type later. That's where we enter the factory design pattern. So why not just map a single product components then? That is a great question. Why not just create a product component and map over it? Well, let's imagine your client adds drones, tablets, or gaming consoles to the site. Each type has new unique properties. So if you use a single product component, you will soon end up with a massive component filled with conditional checks. Think like if statements all over the place. It will get very messy and hard to maintain very quickly. But with the factory pattern, we can cleanly add new product types without rewriting everything. So how we will do this? We will have a folder structure, we will create several components, and each component will be a specific, and then we will have this product factory which will use a design pattern. So we'll have a product component, which will be our base product component, and then we'll have laptop, smartphone, and camera components, which will be with their unique features. And then we will have a product factory.ts, which will be our factory function that creates components for us. Now, why this setup? By keeping each product on its own file, we are ensuring that adding a new product type in the future won't clutter existing code. This approach makes our project organized and scalable as well. So the first step, we want to start with a base product component, and we will create a product component that will hold the basic info for each product. For example, all products will have a name, price, and description. So let's go to our components. I'll create inside my components folder. I'll create a new file and I will call it product.tsx. Okay, and here I'll just create a functional component which I will call it product, and this product will accept an interface as I'm using TypeScript. So I'll create an interface for the properties it does expect, and it will expect a name, which type of string, price, type of number, and description, which is type of string. Okay, now inside here my comments definition, I have to define the type as well. Again, if you're using JavaScript, you don't need to add all these types, but we are using TypeScript here, so I have to define the type. So my product, I have to tell that is going to be a React functional component, so I can do react.fc. Okay, and then I can tell what is the type of the properties is expect. So I defined the type up there, so I'll just add it here, product props. Then inside here, I have to list, of course, the properties we're expecting. So all of them are mandatory, so name, price, and description. Okay, so that's the definition of our component. Now we'll go into the render of the UI, and that will be a simple div, and we'll have, for example, an h2, which will be rendering for us the name property, and then we will have, for example, a p tag with the price, which will display for us the price of the product. And let's have another p tag which will display the description, and we can just let's display the description here from the property. So this component is very generic, right, and will serve as a base for our specific product types. But we don't stop here. We are about to make each product shine with its own features. And this takes us to step number 2. So we will build a specialized component for each product type. So each product has a different attribute that our base product can't cover alone. And here is where creating specialized components like laptop component, smartphone component, and camera component that extend our base product component with the unique details. And let's start creating them one by one. So firstly, I want to create a laptop component. So I'll come here, create a new file, product.tsx. Okay, and of course I will just initialize my component, and I will keep it laptop as well, and I will import the product component I created earlier as well. Now we said our laptop component will display for us, for example, the basic details, which is the title and description and the price, and that we will use this product component. And then we will add some extra information, for example, the RAM and the processor details. For now, I'm going to hard code them, but in real-time scenarios, they'll be coming from some data or somewhere. Okay. So that is our laptop component. So basically, this component needs this product because we need to display, as I said, the name, the price, and description, plus some extra information. And same thing also we will do with the other component, which is smartphone. So I'll create a new component. We'll call it smartphone.tsx. And let's initialize our components, and we will keep it to smartphone. And again, we'll do the same thing. We will import our product. We'll do that right here. And same thing we'll do with the third component, which is our camera component. So we'll go and define a new component. I'll call it camera.tsx. Some extra details here as well, like for example, how many megapixels it have, what is the sensor type, and so on. Now, so each component now has a unique properties that helps customers decide on their purchase. Without the factory pattern, adding these properties in one big product component will get really chaotic. That throws us to the step number 4. We will be creating the product factory function. And now here is where the factory pattern does its magic. The factory function will take in product type and return the correct component based on that type. Okay, so how that will look like? Let's first create a new component. I'll import all those components I created. We import all our custom components. Now we'll create our factory. So I'll create a function, call it product factory, and that will be equal and to accept a property with a type. We'll call it type, and that will be of type string, and that will give us back something. So what we will do, use the switch case, and that will be checking for us the type in the property, and we will make it to lowercase, so we don't make it a case sensitive. So if someone do a mistake and, for example, use a capital letter or something in some type, it should still work. So we'll make it to lowercase, and then we will compare. And here it shines. We will use the cases, okay, and depending on that case type, we will be returning the component which is basically just JavaScript. So our factory here, what it does for us, it checks the type. For example, if it's laptop, we tell, okay, render for us a component laptop. If it's type of smartphone, then of course I give us a smartphone component. And if it is type of camera, give me back the camera component. And if any of these types doesn't exist or is not handled, then we are just giving a default return here, and it can be anything depending on your requirements. So by letting the factory choose the component, our main page will remain clean and readable. And if we add any products, new products in the future, we only need to update this factory function. And this throws us now to the step number 5. We will be displaying the products on the main page. So all what we have to do, we go to the main page, for example your home page or any page is your main page. For me now it will be the page.tsx. And what I will do, I will just hard code an array of types, and then what I will just import our factory now. And I think I forgot to export it, so I'll export my product factory here and I'll export it as default. So I should make my factory available to my application. And we go back to our main function, and what I will do now, or what I have to do, is just map through my array and trigger my my product factory. Simple as that. And that should work as expected. We can go and run our app. So I'll say npm run dev because I'm using Next.js. As we run this in our browser, you can see we got the list of the items. So all we are sharing their base details in all of them. Then we are adding extra details on top of each depending on their type. And this, using this product factory, will keep our page always adaptable. If new products are added, product factory will handle it without us changing the main page code. Even in future, if you want to remove some existing products, that will be easy too. This lets our app grow without a ton of refactoring. So why the factory patterns works here? First thing, the unique properties for each product, like with laptop, cameras and smartphones, each having unique specs. The factory patterns keeps our code clean and prevent bloating one component with irrelevant data. The second, it's easier to maintain. When we add a new product, we just add its components and update product factory. No big refactor required. Then the third, better user experience. Each product type has features that make sense to the user, making our app more intuitive. So this factory pattern isn't just an academic exercise, it is a real solution to handle dynamic components based on complex requirements. Now we have got on an app that scales smoothly and handles unique product specs beautifully. So thanks for tuning in. I hope this example showed why the factory pattern is useful, especially for apps with diverse products or services. Drop a comment if you'd like to see more patterns like this in action, and hit subscribe to keep leveling up your coding skills with real-world examples. Until next time, keep coding and stay curious. Hello React developers, welcome back. Today we are diving into one of the coolest design patterns in React, the render props pattern. By end of this video, you will know how to build flexible and reusable components using this pattern. Plus, we will be using TypeScript to make our code super safe and time with CSS to make it look clean and modern. Let's dive right into it. So what is the render props pattern? In simple terms, it is a pattern where we pass functions as props to a component, and that component uses those functions to display information. This makes it easy to reuse code across components without repeating logic everywhere. Today's example is simple. We are building currency converter, and we will have an input field where users can type in amount in USD, and we will show the converted amount in euros and Japanese yen. Now let's see how this works in the code. First thing, we'll set up our input components, and I've created a blank one at the moment, and this one will handle the currency conversion. And we will add also types to ensure we handle everything safely. We are also going to start using time with CSS to make our component look a little bit nicer for this demo. So let me generate a functional component. I'll still name it input. I need to import a use state hook from React. And reason why is because we'll be tracking the input from the users. We need to store it somewhere. So for today, we just that simple. We just use state, and I'll call it value and set value to help me set up that state, and that will be equal to use state. Okay, and we'll initialize it at 0 at the moment. So here I'll say this one will be type of number because I know my value will be tracking will be a number. Then I'll come inside my UI, and what I will do, I'll just add an input here. Let me close the div. And as this input, what it does is it just type of number to make sure the user only inputting numbers. Then we're reading the value from the state, and then also we are using the onChange function to track the user input. And whenever they write something, we're just storing the state and displaying it again to the UI. And the placeholder, we're just saying enter the amount in USD. Now we said this one will handle for us the render of our converted values. So how we will do that? We will expect now two functions that will pass as props to our components, and that one will be called one render euros and render yen. And of course, because I'm using TypeScript, I need to add type safety. So I'm declaring here the type. So this one is the type of my input props. So I'll come here, I'll say that's type of React.functional component, and it will be expecting some props with the type of input props. Okay, and this input props are just functions which will accept a prop, which will be an object which having a value in it, and that will be type of number, and will give us back in the end, which will return us a React node, which really means HTML, JSX, or whatever you want to call it. Now, we're expecting these props. What we will do with them, we will actually come to our UI and just render them. And basically these functions, what they will do is it just pick up the current value the user entered and then convert it to the currency accordingly. Okay. Now this really looks now interesting. So we use input props to type our component props, which takes two functions, render euros and render yen. Then we also define this render props interface up here, which is the structure of the props we'll pass to these render functions. Then our input component will take the user input, and then we use this render euros and render yen to display those converted values. And with Tailwind, we just sign in the input and the output to make our UI clean and responsive as well. Now let's go back to our page. We want to render this component, and what I will do, I'll just go inside here. And we want now to call our input and pass in our two render functions. Okay, so let me call my input component. I have to import it as well. Now we have to pass on those functions. So our input will be valid. You can see now it's complaining because we said it's expecting these properties as mandatory, right? So let's pass those. Now, here it may look too much, but trust me, it's very simple. Now this render euro and render yen props receive the converted value from the input while the user is typing. And we style it with Tailwind classes to display the amount in green for the euro and purple for the yen. And we make it visually appealing. So using to fixed here, the function here, we just ensures that we're only showing two decimal places for euros and rounded integer for the yen. Now let's go and test this out. I'll just run my code and go to my UI. And you can see that's my UI at the moment. So I should start typing and see the same time the conversion number here. So as I start typing, you can see immediately I can see the converted amount in euros and yen appears right below and updating automatically as we type. It's that much simple. Our input components is reusable and flexible thanks to the render props pattern. Now let's recap of the benefits of using the render props pattern. First thing's reusability. We put our currency conversion logic in one place and reuse it without any duplications. Second thing is flexibility. We can add more currencies or change how they display by just adding more render functions. No changes needed to the input component. Then type safety. With TypeScript we are confident our code is working correctly and handling the data the way we expected. And that is it. If you found this helpful, hit that like button, subscribe, and let me know in the comments if you want more videos on React pattern. Thanks for watching and happy coding. Hey everyone, welcome back. Today we are diving into a powerful design pattern in React called prop combination. And don't worry, I'll explain it in simple steps so that by the end of this video you know exactly how to use it to make your code cleaner and more manageable. And trust me, this trick will make your life a lot easier. So, what is exactly prop combination? Now imagine you have a component that needs to receive a ton of properties. It can get overwhelming. Instead of passing each prop separately, prop combination lets us combine them into one single prop. This keeps our code neat and easy to update. Now, let's dive into the code and see how this works. Now, imagine that we are building a custom product card for an e-commerce site. We want to show the product title, price, color, size, even sale tag if there is a sale. Instead of passing each of these separately, we will pack them into one product info object. Now, this is our product card component, and notice we are using TypeScript to define the types, which make it even clearer and helps catch errors earlier. Here is what's going on our product card. It is taking a single product info prop, which is an object with all our product details. And because we have typed it with TypeScript, we know exactly what to expect. We know that you're expecting the title, the price, the color, the size, and on sale also flag, which is optional. Super clear and super safe. Now let's see how simple it is to use this component. So we'll create a product info in our main page. So I'll go right here. I will create the product info object and then pass it down to my card component. So let's define our object. I'll call it cons product info. You can call this anything you like. And now say for example the title will be cool stuff. And let's say for example the price will be 30. And let's say for example the color will be aqua, and that should be a string aqua. And let's say for example the size will be m. And if you remember, we have that optional property which we'll pass on for today, and say for example on sale is true. Now we'll go inside, and of course first we need to pass on our child component, which is the product card, and we have to import it as well. And you can see it is complaining because we have type safety with TypeScript, and it says that your product info is missing in type object, but it's required in type product card props. Okay, and that's because we didn't pass any props yet. Now, before this design pattern, you will be, for example, doing something like this. Title equal to, for example, that's product info dot title, then price equal to product info dot price. And imagine if you have, I don't know, you have hundreds, or you have I don't know, many. And also this component is reusable, means some properties in a place can be used, in other places can't be. Also maybe these properties are coming directly from an API call, so you can't just go and hard code them every time. And that's why we define this single product info object for today to use as an example, which have all the details of our product. So what we will do here, we'll just remove this, and we will say product info equal to product info. Simple as that. Now when we pass it to our product card, we don't need to pass each prop individually, so just one prop does the job. And because we typed it with TypeScript, if we forget a property or make a mistake, TypeScript will let us know even before we push our code or we try to run it locally. With this approach, our code is cleaner, safer, and much easier to read as well. And if you want to add or change properties in our product info, we don't have to touch a product component at all. So why should we use this prop combination with TypeScript? First thing is cleaner code. It keeps our components free of clutter by bundling related props into one object. Then second, easy to update. We can make changes in one place without needing to adjust every prop individually. And then, of course, because of TypeScript, we have type safety. And TypeScript catches errors before even they hit the browser. It's like having a personal code assistant. Now, if you are working on a big project or just want your code to be more maintainable, this pattern is a lifesaver. And that is it for today. Now you know how to combine your props using TypeScript like a pro. And if you found this useful, make sure to hit that like button and subscribe for more helpful React tips. Thanks for watching, and I will see you in the next one.